Okay, AP Chemistry, let's take a look at this. Obviously, I'm not there today, feeling a little underneath the weather, but I wanted to get this to you so that we can keep moving forward. I want to talk to you today about what we call coffee cup calorimetry or calorimetry. And what the setup for coffee cup calorimetry is this, is we take a coffee cup and the intention of the coffee cup is to limit the amount of energy from the outside that can get in and to limit the amount of energy that's on the inside of this coffee cup from coming out. Now, why would we want that to happen in our study of energy? Well, what ends up happening is this is when we do a chemical reaction, there's very few ways to actually count the energy that comes off of it unless we can quantify the heat. The one nice thing about water is very stable in the amount of energy it needs to raise 1 gram by 1 degree. Okay, and it requires 4.184 joules to do this 1 gram by 1 degree. Okay, so what we end up doing is this: we end up having a coffee cup that's insulated. A lot of times we'll use a double walled one just to make sure that none of this outside energy gets in, and we'll fill it with a known mass of water. Because 1 milliliter equals 1 gram, a lot of times you'll see us use 100 milliliters of water inside the cup, therefore we know we have 100 grams. Okay, so what our goal here is this, is to take a thermometer, stick it into the coffee cup with the water, all right, and then do a heat transfer of some sort to this water so that we can calculate what the energy that's been released is. Okay, there's a couple ways that we can do this, couple scenarios. Um, First of all, we can put a hot object in there. So if we had a steel ball bearing, okay, or a hot or cold object, if we wanted to see how much heat ball bearing could transfer into, or had in it, or could transfer into the water, we could use an object. We could also use, this is also commonly found in dissolution processes, okay, something like dissolving sodium chloride table salt, okay, and this is where this separates into the Na ion and the Cl minus ion. And the third one is a chemical reaction, okay, and so that's where this calorimetry part is useful, is in these three different things. So basically what happens is this, is we have a known quantity or known mass of water, we put the object or the substance in there, and then we see what the temperature change is, okay, and we're going to look at the how much change in temperature we have and how much water it raises that temperature. So for example, if I put 100 milliliters in this coffee cup, okay, which equals 100 grams, and I heated it up, I put, let's say I put a steel ball bearing that's really hot. I put it into the fire flame of a Bunsen burner until it heats up. And it doesn't matter what the temperature of that is, we're just going to drop it in here. And the change in temperature, okay, or the delta T of the H2O is, let's say it's 100 degrees Celsius. Now, it doesn't matter if it's 100 degrees Celsius or 100 degrees Kelvin, because Kelvin and Celsius are the same scale. So 1 degree Celsius equals 1 degree Kelvin. The only difference between the two is our starting point. Celsius starts at 0, Kelvin starts at 273. All right. So I'm going to multiply the mass times the change in temperature, okay, times the specific heat for water, because this ball bearing here is going to be heating up the water a certain degree. So the energy is going to leave the ball bearing and it's going to heat up this water. Now the cool thing is this, we have the styrofoam cup here which is going to protect this energy from leaving it. And we're also going to protect the water inside from getting heat from the outside. Okay, so the whole purpose of insulation is to stop thermal transfer or heat transfer. Okay, so we've got our mass of water, we've got our change in temperature of that water because we dropped the ball bearing in there, and we multiply this by the specific heat of water, okay, which is 4.184 joules per 1 degree, or per 1 gram per 1 degree Celsius. Okay, and what that ends up telling us is this, is that 41,840 joules, okay, of energy is released by the ball bearing into our coffee cup, raising the temperature of that water. All right. We can also put this in 41.8 kilojoules. You'll also see kilojoules used often. Joules is actually a very small unit, so to have things in the hundreds of thousands and millions of joules is pretty common. So that's why we like to use kilojoules. All right. So that's the basics of coffee cup calorimetry.